Hi, this is Russ. I wanted to talk about ignitable liquids, burn patterns associated with fires from NFPA 921. Burn patterns, misinterpreting burn patterns have been a fundamental tool that has led to false convictions. And I think it's worthwhile to understand some limitations of burn patterns of ignitable liquids and arson. Um, Here's an example of flooring. This is a non-porous parquet flooring where gasoline was poured on the example on the left. And what needs to be driven home is that the this example from ignitable liquids, the gasoline, it's exactly the same type of burn pattern you'd expect to see from some kind of drop down from the ceiling or a cardboard box or something along those lines. It's very challenging on non-porous surfaces to determine if something was, ignitable liquid and accelerant such as gasoline or not. And if you look at the actual temperatures of your fuels, flaming combustion, if you look at the temperature for gasoline at 1879 degrees, it's basically the same as the temperature for wood. In fact, if you're using kerosene or diesel, it's about the same. So, generally speaking, you can't make the argument that the burn patterns of the charring, at least on non-porous flooring, was or was not caused by gasoline. There's further analysis you can do, but people have been falsely convicted because people have put, expert witnesses have testified that the burn patterns on wood flooring match an ignitable liquid. And you can't make that call. That's not correct based on the temperature and laboratory evidence. You cannot make that determination through visual observation. So here's an example of a fuel fire on tile flooring. What's interesting here is the tiles will actually start to curl up, and you can actually see a close-up view of this from fuel, but the irony is you're going to see similar results from a cardboard box or a pallet or some kind of wood. Obviously, you'd have some debris there if it was a pallet, but depending on the severity of a fire, it's easy to mask the results from a liquid fuel fire. And this is the kind of scenario where you do have to do further tests. So this is a non-porous surface. This is carpet. You have gasoline poured, um, basically half a liter of gasoline poured and ignited. And after 90 seconds, you can see that the fire really has not spread. And what's interesting about a porous surface such as a carpet, that does show some telltale signs of an ignitable liquid. And it gives this donut shape where the charring is on the outside of the donut, whereas the center of the donut has less severe damage. And the principle there is evaporation. So to understand liquid fuel burning, an important factor to understand is that it's the vapor that ignites. It's not the liquid fuel that ignites. The process of evaporation of a liquid, it results in taking energy away from that liquid because the molecule basically is expanding, or the physical form factor for the material is expanding from a liquid to a gaseous state. And during that expansion, it requires a significant amount of energy. Some of the energy it takes from the liquid itself. So it's this principle of, if you pour gasoline on your hand, for instance, I don't recommend it, but what you'll feel is the gasoline will be cooler. And if you blow on that, it will cool down. It's an evaporative cooling effect. And it's the same principle for carpeted surfaces with ignitable liquids. You'll have this cooling effect. And the very nature of the liquid accelerant, the ignitable liquid, is it will maintain its temperature basically at boiling point. It won't go above that. So it will protect the carpet or the porous material from ignition. So in those kind of conditions, it's a donut pattern is very common. And what's also common is even after self-extinguishment, you're going to see residual gasoline in the carpet pad. And here's an example down in the bottom right corner. This is what the subfloor would look like in such an experiment. So you do see charring, but you will have residual fuel on that carpet pad. So those are the things to look for during an analysis. It's really important that you do sampling. So for instance, in this tile example, it would be challenging to identify if this was an ignitable liquid fire or a fire from, material dropping down from the ceiling or from combustibles like, papers that were on the floor. And this is where you take debris sample and submit that to a laboratory to determine if there were ignitable liquid residue remaining in that debris. Um, let's talk a little bit about floor modeling in general. An interesting factor is that when you pour gasoline on carpet, that carpet, it's going to absorb it, but you're also going to have a wick effect. And when you have a pool fire, depending on the thickness, if you have thick pool of, let's say, gasoline or diesel, you're going to have some convective currents in there. But if that pool fire is really thin, what actually happens is some of the energy for the temperature of that liquid fuel that promotes more rapid vaporization, evaporation rate, some of that energy is actually transferred into the floor. So the thicker the material it is, the less of a percentage of heat transfer from that liquid into the floor. So as the thickness becomes thinner, a greater percentage of the overall energy in that liquid is conveyed to the floor. So what happens is you actually have smaller fires, less heat release rate, HRR, from thin pool fires and thick pool fires. So if you compare a thick pool fire with a fire that's in carpet, that's from ignitable liquid poured on the carpet, it's actually going to be about the same. Whereas on like a parquet floor, a wood floor, if you have an ignitable liquid poured on that and ignited, your heat release rate is going to be substantially less than on carpet. And that's due to a wick effect of the carpet. It'll be about an eighth to a quarter of the overall HRR on a non-porous surface than a porous surface. It's worthwhile to consider that in calculating your radiative heat release from a given size of a fire. Did want to touch a little bit on the Ryan Fitness Center. This was a fire where a young man was convicted of arson. What's interesting, as part of the conviction, he also was sentenced convicted for the death of a couple firefighters. And the arson investigators that testified in that trial indicated that there were telltale signs of ignitable liquids on the racquetball court floor. Well, that was kind of a travesty of justice, because the scientific research shows that you can't tell that. There's nothing there. And here's the irony on subsequent testing. No residue of a fossil fuel, a hydrocarbon, was found. There's no indication of gasoline. So then the witness, there's a so-called expert witness testified, well, then he probably used alcohol. But there was no trace of alcohol in the laboratory research. And then the expert witness said, well, the forensic dog used to, hunt down traces of fuels, they hit on this spot. And therefore, it must have been alcohol, and it also must have been at levels that were below laboratory tracing because of alcohol being diluted with water. And consequently, the dog could smell it, the residue, but our lab couldn't. And that's the kind of testimony that's not allowed anymore. That's a breach of the scientific method. And what's even further more exacerbating about the situation is that this particular fitness center, they did have in its past alcohol serving at this general location. So you could easily say that, what the dog was sniffing was alcohol from, this little, bar that was used here at this fitness center. So the point was, this gentleman was finally exonerated, but he was convicted and given a prison sentence for this. So it just demonstrates that forensic tools, you do need solid data associated with them, and using patterns especially on non-porous flooring, it's not scientifically justifiable. You can't do that. Another example I think is interesting. There was a gentleman convicted of arson because the arson investigator, the so-called expert witness, and I want to keep in mind the expert witnesses almost uniformly are firefighters that went through, some fire academies, like at the National Fire Academy for a couple of weeks, or sat through a few lessons. And I sat through those lessons myself. So I can tell, but I have a little bit more background in terms of the science side. And these individuals do not typically have any solid science background. They may have been a firefighter for 20 years and been a part of that, but these are the people the prosecutors typically call as their forensic experts. And that's just because the matriculation process in fire departments, they focus on taking firefighters and training them rather than having engineers or scientists going through that process. So it's really a broken model on how this whole system works. But I want to give you another example. So you had a fire, and the forensic expert, the firefighter that was called upon for testimony in this, testified that there were ignitable fuel patterns at the back and the front of this structure. Well, the gentleman being convicted of arson, he pushed back. He stated he's innocent. He had nothing to do with this. And it wasn't until the turnout gear, that's the protective gear firefighters wear, they actually crawled in on the back and the front, so they had the residue of the ash on them, and there was no signs of ignitable fuels whatsoever that would have been present in that charcoal at the front and the back. So that exonerated the individual. So it just demonstrates how this tool, it really is genuinely weaponized. Just the general ignorance of fire patterns. It's dangerous. So if you ever are in court as a jurist or a defendant and somebody mentions this principle of fire patterns, push back and make sure that there's solid scientific evidence to support anything that's being stated, such as laboratory tests of the debris. And also, I mentioned this on another one of my videos. Frequently gasoline is used as a solvent. Gasoline is also used to cut paint, oil-based paint. There's been one very specific case. The Innocence Project revoked or overturned a conviction of a gentleman. I did go through this some time ago in another one of my presentations, but what had happened was residue of fuel was found, and this gentleman was convicted of arson. But upon further examination of that fuel, it was leaded fuel. And obviously, at the time of the conviction, leaded fuel was not being sold. So there's an example. Just lucky enough that the fuel was spilt back in, when leaded fuel was common. If that same thing had happened in our era, where leaded fuel is illegal, it would have been hard to distinguish. So I'm very confident there's many innocent people in prison right now because of false testimony or ignorant testimony of expert witnesses. I'm certain there's numerous civil litigation payouts also because of this principle. So just something to keep in mind and caution, open-minded people. Be wise. Be very cautious about accepting expert testimony in this field. Make sure the individuals that are testifying have solid scientific and engineering credentials and are not simply firefighters. Firefighters are not qualified to testify as expert witness on arson. Do not have the background to do it. Not in an era of enlightened science. So let's run through the conclusion. The temperature between hydrocarbons and cellulose-based materials are basically identical. You can't tell differences for burn patterns on non-porous surfaces between ignitable liquids and cardboard boxes, wood. Carpet burn patterns may show ignitable liquid signs, but if you're going past flashover, flashover is defined when you have ventilation limited fire. You don't have enough oxygen is what it comes down to. At that point, you have significant pyrolysis or basically charring of material. It's very common once you hit about 600 degrees Celsius at the upper layer at your ceiling level. Basically, the whole room bursts out into fire and become ventilation limited. So at that point, burn patterns are destroyed. So any kind of burn patterns post flashover that prosecutor witness is bringing forth, push back on. There's likely some weaknesses in their forensic analysis. Sampling for ignitable liquids, really, you have to caution yourself. I use that example of leaded versus unleaded gas or alcohol in an area. Be very cautious about the samples as well to understand the history of the area. But sampling really is the only tool that can be used, particularly on non-porous surfaces. Anyway, hey, thanks for your time watching this. I hope this was beneficial to you, and have a good day.